Look closely at a flickering flame and you aren't actually seeing a solid object, but a violent, beautiful reorganization of reality itself. Think about the campfire's warmth on a cold night, or the steady blue roar of a furnace. These sights and sounds are deeply woven into our human history, serving as our oldest companions in the dark. Yet inside those glowing tongues of light, a profound physical mystery is unfolding that most people completely misinterpret. To truly grasp why things ignite is to travel through the invisible world of atoms, across the sprawling life of ancient forests, and directly into the heart of the stars themselves. We are looking at a hidden symmetry within our universe, a bridge between the celestial and the mundane. Fire isn't just a tool for destruction or a simple means of survival for a primitive species. It serves as a vivid, glowing demonstration of the deep laws that dictate how energy, matter, and existence function on a fundamental level. This investigation strips away the visual surface of the blaze to reveal the elegant, invisible mechanics that generate light and heat from what seems like thin air. At its foundation, combustion is a narrative of chemical longing and atomic desire. Our lead actors in this drama are carbon and oxygen. When kept apart, they represent a massive amount of unspent potential, a tension waiting to be snapped. The oxygen floating in our breeze and the carbon locked tightly inside a wooden plank feel a powerful magnetic-like attraction toward one another. Joining together allows them to reach a more grounded, tranquil, and stable state of existence. When these elements finally collide to create carbon dioxide, they discard a massive surplus of energy that they no longer need to hold on to. But there is a massive hurdle blocking their path to this union. For these atoms to unite, they must first scale an energetic mountain, similar to pushing a heavy stone to a peak before it can roll down the other side into the valley. Under normal conditions, these atoms simply lack the chaotic vibration needed to climb that summit. They bump into each other and ricochet away trillions of times every second, never getting close enough to actually bond. This explains why your wooden furniture, your floors, or the books on your shelf don't spontaneously combust in our oxygen-heavy atmosphere. The chemical desire is there, but the momentum is missing. Moving from stillness to an inferno requires a specific nudge, what scientists call activation energy. This is the spark that triggers the avalanche. When you strike a match, you concentrate intense friction into a microscopic point, supercharging a small group of atoms. Their movement turns frantic, their impacts turn brutal and high speed. A few trailblazing pairs of carbon and oxygen, now vibrating with enough speed, finally crest the hill. They snap into a molecular partnership, dumping their stored energy into the immediate surroundings. This released power doesn't just dissipate into nothingness, it manifests as thermal agitation, which shakes the nearby atoms like a drum. Suddenly, those neighbors also possess the speed to leap over the barrier. They react, shedding even more heat, which excites even more particles in an ever-expanding radius. What starts as a tiny ripple quickly swells into a massive, self-sustaining loop of chain reactions. This is the core truth of fire. It is an exponential, self-sustaining loop of chain reactions. One event sparks two, two spark four, and in a blink, billions of atoms are clicking together in a coordinated eruption of power. The fire becomes visible not through magic, but because it has become a runaway cycle. The thermal energy produced by the first reaction provides the exact fuel needed for the next. That glow we observe is the radiant stage where this atomic rearrangement happens. Extreme heat causes tiny molecules and soot fragments to turn incandescent, bleeding out that iconic yellow and red glow. Electrons inside disturbed atoms jump to higher orbits, and as they settle back down, they spit out photons, the shimmering ghost-like dance of the fire itself. Consequently, fire is a process, not a thing. Fire is the beautiful catastrophe of matter seeking a more stable home. It is a fierce transition where buried energy makes a spectacular exit. To understand what is actually being set free, we must look at where the fuel originated. This brings us to a breathtaking biological realization. Think about a massive oak tree. Its heavy trunk and thick limbs seem to be pulled directly from the dirt beneath it. Most people believe plants construct their bodies from the soil, sucking up the earth to build their wood. This is a total sensory deception. A simple thought experiment proves it. If you weighed a bucket of dry earth, planted a tiny sapling, and gave it nothing but water for a decade until it grew into a giant tree, what would happen? If you then pulled the tree out and weighed the dirt again, a mass would be almost exactly the same, minus a few tiny minerals. The hundreds of pounds of solid wood and bark didn't come from the ground. They were actually pulled out of the invisible sky. The fundamental building block is carbon dioxide, a gas drifting through the air. Using the alchemy of photosynthesis, a tree utilizes sunlight as its primary currency to perform a feat of atomic engineering. Solar photons provide the raw power to surgically rip the carbon atom away from its oxygen twins. The tree keeps the carbon, weaving it with water from the roots into the intricate sugars and cellulose that form the physical tree. The oxygen is then tossed back into the sky as a byproduct. This mechanism is atom for atom, the perfect inverse of a fire. The tree is a solar-powered engine that spends years prying carbon and oxygen apart, locking the sun's radiance inside those newly created chemical links. Therefore, a tree is effectively a battery, a massive storage unit for captured light and separated atoms. Because of this, a log burning in a fireplace isn't just wood turning to ash, it's the liberation of ancient sunlight. The match offers the necessary shove, and that solar energy, held prisoner for years within molecular cages, is suddenly set free. The carbon, which the tree worked so hard to isolate, frantically reunites with the oxygen in the air. The warmth you feel against your skin in front of a hearth is literally the sun's rays from years ago being recycled in a luminous display. Every spark is a packet of solar power that was once caught by a green leaf, stored as potential, and finally allowed to escape. This perspective reframes fire as part of a massive circular epic of terrestrial life. The very oxygen that fills our lungs, making both fire and animal life possible, is the gathered waste of plants over eons of time. The early atmosphere of Earth had almost no free oxygen. It was a toxic gas to the first living things. As forests spread, they re-engineered the planet, filling the sky with this highly reactive element. Animals, including us, evolved to harness this chemical pressure. The way your cells process food, the burning of nutrients, is essentially the same reaction as a wood fire. It's a controlled, biological version of that same dance, releasing energy not as a flame, but in small packets of ATP that fuel every thought you have and every step you take. Every human breath is a slow and silent fire sustaining life. Your body is, in a very real chemical sense, a cool and carefully throttled blaze, constantly merging carbon with oxygen and breathing out the resulting gas. The flame is the meeting point of this eternal cycle. Energy flows from the sun to the plants, which store it by pulling atoms apart, then to fire and animals, which release it by bringing those atoms back together. Fire makes this planet-wide metabolism move fast and become visible. It is the universe's way of finishing the circuit with a theatrical flourish. The gray ash left behind is just the small mineral trace from the earth, the only part of the tree that actually came from the soil, while the rest of its body has vanished back into the clouds as vapor, waiting for the next forest to catch it again. Viewing fire through this lens changes it from a common sight into a window into the fundamental nature of things. It shows us how systems like wood and oxygen exist in a state of hungry balance, waiting for a spark. It proves the conservation of energy as it shifts from light to chemical bonds to heat. It uncovers the intimate pull of atoms that governs all of chemistry. To stare into a fire is to watch a cosmic tension resolve itself, to see the ghost of stored sunlight, and to witness the rhythmic engine of life, all captured in a single, fleeting moment of matter finding its way back to center. This profound realization allows us to see the world as a vibrant, interconnected web of energy transformations. Each time we observe a forest, we are seeing a silent army of solar batteries charging up, preparing to eventually release their power back to the atmosphere. Each time we feel the warmth of a candle, we are experiencing the sudden resolution of a separation that began high in the atmosphere of our star. Our world is a theater of these atomic reunions, a grand play where nothing is ever truly lost, only converted. The carbon in your own body may have once been part of a prehistoric fern or an ancient bonfire, just as the oxygen you inhale today was once the discarded breath of a trilobite-era sea plant. We are literal participants in this fiery metabolism, walking, thinking, and dreaming because of the same chemical affinity that makes a match strike hot. The boundaries between the living tree, the roaring fire, and the breathing human are much thinner than our senses suggest. We are all solar-powered. We are all temporary vessels for the sun's brilliance. Understanding this doesn't diminish the beauty of a flame, it amplifies it until the fire becomes a bridge between the smallest atom and the vastness of the solar system. It is a reminder that even in the cold vacuum of space, the laws of attraction and the drive towards stability create the very conditions that allow us to exist here on this warm, oxygenated rock. Let this knowledge stay with you the next time you watch a sunbeam hit a leaf or a spark leap from a fireplace. You are witnessing the fundamental currency of the cosmos being traded, saved, and spent. You are witnessing the very breath of the planet. It is a cycle that has continued for billions of years and will continue long after our own inner fires have quieted. To see the world this way is to find a sense of belonging in the very chemistry of the stars. If this journey into the light changed how you see the world, please like the video and join us here at Winds of Thought for more deep dives into the mechanics of reality. Together, we will continue to explore the hidden truths that govern our existence and the beautiful mysteries that lie just beneath the surface of the everyday world. Thank you for being part of this exploration of the hard science that defines our theory of everything. Until next time, keep looking deeper into the flicker. Stay curious, stay questioning, and never stop looking for the sunlight hidden in the dark.